Hi AP Calc. We are going to finish up our 2.3 notes just on our product rule and trig derivatives, and then you will get work time for the rest of class today to keep going with those two, as well as a little bit of a review of derivatives we know so far. We are going to jump in to what I'm calling 2.3 day 2, even though it'll be the third day, tomorrow. That will be over the quotient rule and higher order derivatives, so get excited. I really like both of them. But today, finishing up your 2.3 notes, this is the note sheet that we started last week, Wednesday? Yes, last time we met before senior retreat. So get your notes back out and follow along with those. If you need to copy down the problems, in a notebook in the meantime, so you can have the video full screen, do what your heart desires, but then problem solve and make sure you get these notes filled in for me. So we left off on example 5, and we want to determine the derivative of the function h of x. Now, h of x has 3 separate pieces to it, which is super, super fun. So the way that we do this, well, there's a couple different ways. The first way I'm going to show you is what we do is we just consider, remember our product rule, it's always about our first function and our second function that together, when multiplied, make up our overall function, h of x. Our first function is just also going to be a product, and that's totally okay. So this is like a product rule inside of the product rule. So, our derivative, h prime of x, well, it's going to be the derivative of the first times the second plus the first times the derivative of the second. So, if we call this guy f and this guy g, then h prime of x is going to be f prime times g plus f g prime. Well, that's handy, but we have to consider f prime of x, and that's going to be a whole process by itself. So f prime of x, we break down into, okay, here's the first piece of that function, and here's the second piece of that function. So the derivative, f prime of x, is going to be the derivative of the first piece, derivative of 3x is 3, times the second, sine of x, plus the first, 3x, times the derivative of the second. The derivative of sine is cosine. So that is what we will be using just for f prime of x. So that is all going right there. So then we've got f prime of x times g of x. Well, g of x is cotangent x plus the first 3x sine x times the derivative of the second. The derivative of cotangent is negative cosecant squared. Cool. And this all together makes up h prime of x equals. So then we can simplify this and make it look nicer. Again, for the sake of multiple choice on the AP exam, this is probably not going to be an answer given. We can make this look a lot nicer. That's going to involve distributing, whoa, that's a big yellow marker. Distributing, and then simplifying, and then negative cosecant squared times sine. We're going to get some things to cancel, etc., etc., etc. But let's go back to the beginning. If we look at this, we've got sine times cotangent. What is cotangent? It is cosine over sine. What happens when you have sine times cosine over sine? Your sines cancel. So h of x is really 3x times cosine of x. So now when we do our derivative, we do our product rule, it's way less painful. We're going to get the same answer, but I'm going to go ahead and guess that you don't want to simplify that first guy. So on your homework tonight, on the worksheet, and as on, anything, if you can ever simplify first and make your life easier before you begin, do it. So instead, we're going to have h prime of x be the derivative of the first function. Well, now our first function is just 3x. The derivative of that is 3. Derivative of the first times the second, cosine x plus the first 3x times the derivative of the second. Derivative of cosine is negative sine. And now we're done. Here's our final answer. Ta-da! So, like I said, for the AP exam, we are going to be given a whole bunch of different functions and asked about their derivatives. Now, the main way that we represent functions that we have practiced so far is by equations, right? But that's not the only way we can represent them. We can represent them with points, with tables, with graphs, with words. Super fun. So we have to be comfortable with all of those. So in example 6, let f be a differentiable function. Okay, that's important. It just means it has a derivative such that, okay, they give us this point, and they give us the derivative of the function evaluated at that same point. If g of x is this guy, find the value of g prime of 3. Cool. I would start first by considering g prime of x, right? G prime of x is going to be is going to be found using our product rule. So because g of x is a product function, we've got x squared as our first and f of x as our second, that's fine. That's all we need. So g prime of x, our product rule says the derivative of the product function is the derivative of the first function, 2x, times the second, plus the first times the derivative of the second. F prime of x. And then, if I just want to find g prime of 3, just like always, wherever I see an x, I'm going to swap it out with 3. So I'm taking 2 times 3 times f of 3. Oh, good thing that was one of the points they gave me. Plus 3 squared times f prime of 3. We know all of these pieces. So 2 times 3, we've got 6. Times f of 3, well, that was the 4 that they gave us. F of 3 is 4. Cool. Plus 3 squared, we get 9. Times f prime of 3 is 5. And then we simplify. So g prime of 3 is going to be 24 plus 45. So all together, we're going to get 69. G prime of 3 equals 69. This would most likely be a multiple choice problem, but in the off chance that it wasn't, make sure that we're careful saying that this first line is not equal to the second line, right? We can't just put in equals when we evaluate it at 3. So separate thoughts. But g prime of 3 is 69. Example 7 would be a free response problem. So we've got the table below giving values of the differentiable function, so it has a derivative, f, and its derivative f prime at selected values of x. Let h be the function defined by, okay, so h is a product function, which is completely unrelated to our table. Cool, that's fun. So, using the values from the table, estimate f prime of 4. Now, be careful. F prime of 4, we are going to evaluate not by averaging f prime of 3 and f prime of 5, but rather using our idea of the derivative. So the derivative is the slope, right? Well, if you've got these 2 points, you've got the x-coordinate of 3 and 5, and we've got -1 and 4, our derivative is going to be approximated using the slope between those points. So f prime of 4 is approximately equal to f of 5 minus f of 3 over 5 minus 3. So notice we had approximately equal to, but that is equal to. So this piece is equal to. So now we get to start using a whole bunch of equal signs. F of 5 is 4 minus -1 all over 5 minus 3, we get 2. 4 plus 1 is 5 over 2. Let's keep it 5 halves. So f prime of 4 is about 5/2. And then we're letting m be the function defined by f of x plus h of x. Okay, now we need h from up above. We want to know m prime of 3. Okay. Well, first let's consider m prime of x. M prime of x is going to be, okay, we're just adding two functions. Finding the derivative of the sum is just the sum of the derivatives. So it's f prime plus h prime. Cool. But h of x was a product function. So h prime of x, we're going to need to use our product rule. So h prime of x, okay, f prime of x plus, okay, the derivative of the first piece, let's get our different colors out. So the derivative of the first, 2x, times the second, sine x, plus the first, 2x, nope, that's a lie, x squared, times the derivative of the second, derivative of sine is cosine. So now finding m and, timeout, that would probably be a point on the AP exam. So can you find m prime of x, and are you clear in doing so? Ta-da, we found m prime of x. And then the next point would probably come from evaluating m prime of 3. So that's going to be f prime of 3 plus h prime of 3, which let's just evaluate this function at 3. Times the sine of 3 plus 3 squared cosine of 3. So f prime of 3 was thankfully one of our points given. It was 8. So it's going to be 8 plus 6 sine of 3 plus 3 squared is 9 times the cosine of 3. And that's as much as we can simplify it without a calculator. This might be on a calculator-friendly portion, so you might just be able to get a decimal approximation, but why bother? This is good enough. You have a numerical answer, leave it. There's m prime of 3. Now we're letting n be the function f of x times h of x. And I want to find n prime of 5. Good news. We get to do the product rule twice. There's no way we can avoid it. So n prime of x is going to be, well, now we very clearly see that we have two functions making up n of x. So it's going to be the derivative of the first times the second plus the first times the derivative of the second. Well, thankfully, from the problem up above, we just found what h prime of x was. So we're just going to plug that straight in, and we'll be okay. So we've got f prime of x times h of x. And actually, this probably isn't so, well, yeah, okay, keep going. So f prime of x times h of x. Well, I would say let's go ahead and write in what h of x is. It's x squared sine x plus f of x, which again was given by the table up above, so we have no equation we can plug in for it, times h prime of x, okay, 2x sine x plus x squared cosine x. How fun. Cool. Now, and again, that would be a point on the AP exam. So now let's find n prime of 5. So f prime of 5, we go back up, f prime evaluated at 5, that is 3. Times, okay, 5 squared times the sine of 5, plus, what was f of 5? 4. Cool. Times 2 times 5 times the sine of 5, plus 5 squared times the cosine of 5. Big parentheses. And you know what? We're in a numerical answer, so on the AP exam, leave it here. This is totally fine. For our sake, and for this meaning nothing to us, we're going to go ahead and keep simplifying just a little bit further so that we feel a little bit more sane. So 3 times 5 squared times the sine of 5. 5 squared is 25 times 3 is 75 times the sine of 5, which who knows what that is. plus 4 times 10 sine 5 plus 25 cosine of 5. And maybe we can go ahead and distribute 75 sine of 5 plus 40 sine 5 plus 100 cosine of 5. And then maybe we see that we've got 75 sine 5 plus 40 sine 5. And so altogether we can add those 115 times the sine of 5 plus 100 times the cosine of 5. There's n prime of 5 for you. So for the remainder of class, you can work on your worksheet, and we are going to continue on with section 2.3 tomorrow. Wednesday, we are going to review, and on Thursday, we'll have a quiz over all of our derivative rules so far.